Alright, this next problem is going to be optimizing the distance from a function to a point. Alright, this is number 6 on your homework assignment. So here we go. Oh, number 5 actually. I believe number 5. Alright, so a function to a point. Let's say we have a function f of x is equal to 2x minus 5, which that looks like so. Alright, and we have, let's say we have the point 0, 1, okay, and we want to find the minimum distance, okay, the minimum distance d from the point to the line f of x. Alright, so we're minimizing distance. Okay, minimizing distance. Alright, so what we need here is the distance formula, okay, because that's what we're minimizing. So distance is equal to the square root of x2 minus x1 squared minus y2 minus y1 squared. Okay, it's basically the reverse of the Pythagorean theorem. Okay, actually this is plus. Yeah, this is the reverse of the Pythagorean theorem, because you have a squared, c squared equals a squared plus b squared. All we're doing is saying c is equal to the square root of a squared plus b squared. A and b just happen to be the difference in the x's and the difference in the y's. Okay, so what we need to do is put real values in here. Alright, so essentially this could end up being my x1 and my y1 if I wanted it to, or x2 and y2. So therefore I'm going to substitute. Okay, so I've substituted I've substituted my x1 for 0 and my y1 for 1. Okay, now I need real values for x2 and y2. Now x2 and y2 represent every single point on this line. x2 and y2 represent every single point on this line. So x2 and y2 represent every single point on the line. Well, I want to keep this in terms of x, so this x2 can just be a generalized x. It could just be at x, that's fine. But y2 needs to be every y value on this line. Well, I think of every y value, every point on this line is x comma f of x. So every point on this line is x comma f of x. Even the closest point to the point there is x comma f of x. Well, you notice we substituted x for x2. We're not going to do f of x. Well, we can do f of x for y2. We can go that route. Yeah, we could substitute it in there. But what is f of x? What is f of x? Well, there's an equation for it. Excuse me. There's an equation for it right here, sitting there looking at you. So we can actually write f of x in terms of x for this. Okay, so you end up being x squared plus f of x in terms of x is 2x minus 5 minus 1 squared. Alright, simplifying that yields the following: x squared plus 2x minus 6 squared. I'm going to FOIL that because I don't want to take a derivative of something ugly. So square root of x squared plus 4x squared minus 24x plus 36. Okay, combine like terms. Okay. 5x squared minus 24x plus 36. Okay, so I'm going to take the derivative. Now this may look really ugly, but the solution is not so fierce. Alright, so this is to the 1/2, so it's a chain rule. Okay, so d prime is going to equal
Casey Shields,
1/2
report to the principal's office immediately.
5x
Shields, report
squared
to the
minus
principal's office immediately.
24x plus 36 to the negative 1/2 right there times the derivative of the inside, 10x minus 24. Okay, and so d prime is going to equal 1 over 2, and this is on the bottom, 5x squared minus 24x plus 36 to the negative 1/2 to the positive 1/2 now, and 10x minus 24. Now if you remember when we were doing first and second derivative test, we would set the top equal to 0 and the bottom equal to 0, but in this case I am just looking for where the top is essentially equal to 0. So I am minimizing this by setting it equal to 0, and I'll just put ditto, and setting the top equal to 0 right here. So 10x equals 24, x is equal to 2.4. Okay, now what would so that's a good information right there. Okay, x is equal to 2.4. That's this point up here, right? So what is the y? What is the y? So we're going to substitute, okay, here to find my y. So f of 2.4 is equal to 2 times 2.4, which is 4.8 minus 5, which is negative 0.2. Okay? Oh, can't see that. Sorry. F of 2.4 equals negative 0.2. So the point right here is 2.4 comma negative 0.2. And it looks about right. Now we have to substitute that into the distance formula, okay, to find out my real minimum distance. So it ends up being d is equal to, what's the first, we're going to do the second x and the second y. So x2 is 2.4 minus x1 is 0 squared plus y2 is negative 0.2 plus, or sorry, minus, excuse me, minus y1 is 1 squared. So this ends up being 2.4 squared plus negative 1.2 squared. And so I'm just going to use my calculator. Excuse me. Sorry, I'm in a rush, guys, so I apologize for this being in haste. So the square root of 2.4 squared, and I know this is positive anyway, so I'm just going to do plus 1.2 squared, and there we go. The shortest distance between the point 0, 1 and the function f of x equals 2x minus 5 is 2.683. Alright guys, I appreciate you following. Alright, get that homework done.